Hi folks, so we are continuing in our section of 4.5. We just got done looking at the period of our sine and cosine curves. So now we're going to look at the last part of this, which is the translations of sine and cosine. So the last two variables, c and d, cause translations of the sine and cosine curve. So for y equal to a sine of bx minus c and y equal to a cosine of bx minus c, c causes horizontal shifts in the graphs. Now we should kind of already know this based on, again, our translations back in chapter 1. So when we're modifying the value of x, in this case we can see that it will cause a shift either left to the right. So depending on what the value of c is, that's the primary um, component that will shift it left or shift it right. But let's take a look at the whole picture. So when we have a b in there and a c, both of those things are affecting the value of x. So we have to take both of those into account when we're looking at the shift. So it'll be a shift of a sine of bx will be shifted by c over b. So c over b. This number is called the phase shift. So anytime you're looking at a shift horizontally, technically it's a phase shift when it's sine and cosine. So in total, for y equal a sine of bx minus c and y equals a cosine of bx minus c, we have, drum roll, we have all of this. So one of the things we do want to assume though is that b is greater than 0. So we know that the amplitude is the absolute value of a, because remember, just because a is negative, we don't want to look at that's going to give us the lowest value, not the highest. So we want the highest value. So absolute value. The period is 2 pi over b. And now we can look at the endpoints of one cycle. If we look at the endpoints of one cycle, that'll dictate everything else that happens in between. So we just have to look at what happens to those two ends. So our left endpoint, which we'll just label LE for short, will be whatever the phase shift is. So X will be C over B. And the right endpoint, RE for short, is going to be X equals the period plus the shift. So that's a nice way to think of it. So this is always going to be the phase shift. And this is always going to be the period plus the shift. That's a nice, easy way to remember these two endpoints. So let's see if we can put this into practice in this next example. So we got a little bit more complicated one here. We got y equals 2/3 cosine of x over 2 minus pi over 4. Okay, so we got a lot to unpackage here. But let's start with the easy stuff. So we got the amplitude. The amplitude's always based on the number in front, so we know that that's going to be 2/3. All right, so we need our period. So just like the previous problem, remember b is going to be equal to 1/2, so we know the period is 2 pi over 1/2, which we already said was 4 pi. All right, so those are the things we already did. Now let's worry about these endpoints. So we have our left endpoint should be equal to our phase shift. So now we got to be careful. C is what in this problem? Now some of you might be tempted to say it's negative pi over 4, but the formula, remember, is with a negative built into it. So we want to be careful. So that negative that's already in there means that our C value is positive. So positive pi over 4 over B, which was 1/2. So if we simplify that, if we multiply the top and bottom by 4, that's going to end up giving us pi over 2. So our left endpoint is pi over 2, and so now our right endpoint, and if we use our cheat up here that you can't see, our period plus the shift. Remember, that's always the right endpoint, so we just have to simplify that. So our period was 4 pi, our left endpoint was pi over 2. So if we do 4 pi plus pi over 2, well, 4 pi is the same as 8 pi over 2. 8 pi over 2 plus another 1 pi over 2 is going to be a 9 pi over 2. So leaving those as improper fractions is probably going to be to your best benefit. So we should have enough to get our graph now. So we have our period is 2/3, so we know that's our vertical. And now, what did we say before? We said the fourth dash is the period. So don't worry about this left and right endpoint stuff yet. Just worry about getting your dashes. So 4 pi is going to be the fourth dash. And we already know that these other ones should be easy. And we can even do this dash here, which we know should be 5 pi. Now again, keep in mind this is always going to be the case. Your horizontal scale is not going to match your vertical scale. So these are all skewed drawings, but it's just to give you a rough idea in your mind what it looks like. All right, so now we have to tackle our left and right endpoints. So now normally we would start where? Because it's cosine, normally we would start right here. But because our left endpoint is pi over 2, which would have to be right here, halfway between 0 and pi, we know that we actually are starting right here. So again, everything's shifted pi over 2 units. So normally we would go down to here, and then we'd go down to here, and there, and then back up here. But all of those 5 key points are all shifted to the right pi over 2 units. So this point here is going to get shifted to there. This one is shifted to here, and so on. Now, if you don't like all the extra stuff in there, you know, these X's, obviously you can erase those. Once you do this a few times, you won't need those X's. So just erase those the first couple of times, that way it looks cleaner. And that's it. Now we just have to sketch in our curve. And there you have it. So, all right. So that is our horizontal shifts. Now again, be careful about that sign in there. When it's plus, that means it's actually shifted to the left. When it's minus, it's shifted to the right, just like we saw here. It's shifted to the right, pi over 2 units. So C over B. Now for the last variable, D, it's going to cause our vertical shifts, which again should be familiar to you from chapter 1. So let's see if we can squeak this out. All right, so we have y equals 2 plus the sine of 2 pi over 3x. Interesting. Now we should automatically know that we have to go up 2 because of this plus 2 in the front. Now this could be in the front or it could be at the end. The big thing is that it's not inside the parentheses. So very important. But let's do all of our key ingredients. So what's our amplitude going to be for this one? Don't say 2. The variable in front of the sine is nothing, so it must be a 1. All right, and so now we need our period. So 2 pi over b. So what is b in this case? Yeah, we have a really complicated b. We got 2 pi over 3. So that whole thing is going to be in the bottom. Now, if you know your same switch flip when you're dividing fractions, then you can see that this would reduce down to 3. So the period in this case is 3. Now, what about our left and right endpoints? Is there any shifts? No shifts in this one. There's no plus or minus inside of the parentheses. So there's no shifts, no horizontal shifts. No horizontal shifts. And then we also said, last but not least, this is going to go up too. So let's do the same thing with our little X's, and then we'll erase them. But before we get to that point, let's label. So our amplitude is 1. So 1, -1. And we might as well number the rest of these. Somebody must have put them in there for something. All right, so we have our vertical axis done. And so now let's get our horizontal. So what was our trick? The fourth dash is always the period. So our period is 3. So this dash is 3. So now let's get the rest of them. So the one halfway in between should be 3/2. That's half of 3. And if we want to do half of that, then that must be 3/4. Now, can you use decimals? Of course, but using fractions is pretty easy too. And then what was the trick for the third one? You have to multiply the first one by 3. So if we multiply 3/4 times 3, we get 9/4. And we know the dash on the left should be the negative of the first. All right, so there should be our graph. We're dealing with sine, so we know that that starts at the origin, and then it goes up, then down, and up. So now we just have to take each of those x's and shift them all up 2 units. So this one's going to get shifted to here. So we can lose that one. This one gets shifted up to there. This one up to here. This one, 1, 2. 1, 2. So our sine curve is kind of floating above the x-axis, but that's all right. And now let's sketch it in. And there we have it. Now again, technically these go on forever in both directions, so if we wanted to put arrows on them, we could, but it's not a requirement. So, but that covers all the different translations. Now there's going to be one more video that goes through a couple of applications of these problems, so we'll just see those, which will be helpful for the homework. So, see you soon.